Hey, hey, how are you? Good evening. Hello. Good evening, everyone, and welcome to this very special day today. Today is a Science Day and also happens to be Wednesday Colloquium Day. So, this we are today on the behalf of TIFR Alumni Association. We have organized this very special Science Day lecture as a part of TIFR Wednesday Colloquium. And first of all, thanks to Professor Jyotishman for who is the coordinator of this Wednesday colloquium. So he has given us this slot so generously. So thank you very much, and also welcome all of you. So first, today we have a great surprise and a great honor that Professor Mohanty, the chairman of DAE and also the secretary DAE, who has come here as a big surprise to us and as a great honor for us. So welcome, sir. So now I request also President of TAA, Professor Vahia, to welcome Professor Vyas for today's lecture. So please. Our special guest, Professor Vyas, who has been former chairman of DAE. That special book is a collection of TIFR artworks. Now I request our director, Professor Jairam Chenglu, to welcome our DAE chairman and AEC secretary, Professor Mohanty, to TIFR. Please. Yes, sir. So now I request our director, Professor Jairam Chenglu, to say a few words.
Yeah. Thank you, Professor Prabhu, and I'll keep my sort of welcome brief. Firstly, of course, I'd like to say it's a real great pleasure to welcome all of you for this public talk organized by the TIFR Alumni Association. As we all know, the TIFR Alumni Association is one of the pillars of the TIFR family, and their commitment and drive is an important factor that continues to motivate all of us at TIFR as we continue along this path of excellence. The programs that the TAA organizes, such as events to commemorate 50 years of graduate school at TIFR or 75 years of TIFR itself, help us not only to reconnect with our past, but also to rededicate ourselves to the future. So one of the traditions that is kept alive by the TAA is the organization of a talk by an eminent speaker on a topic of widespread interest on the occasion of Science Day. This year is no different, and we have the very good fortune of having with us Mr. KN Vyas, the former secretary of the DAE and a member of the TIFR Council. Mr. Vyas will speak about one of the most important challenges facing not just India, but the entire world, namely the challenge of achieving net zero emission and the role that nuclear power could play in helping us reaching that goal. I can think of no better person to give this talk, and I'm very much looking forward to it. I'm sure y'all are too. So without further ado, I'll end over here. Welcome again.
Thank you, Director Professor Jairam. Now I request TAA President Professor Vahia to do this welcome address.
First of all, as President of Alumni Association, let me welcome you all here. So Alumni Association is been around for a long time now, and the idea is to keep communicating with TIFR staff and also with the alumni to have a mutually productive interactions. We have had some conferences about the past of TIFR. We are looking to one more meeting in the future of TIFR, plus to organize lectures on special events. We have one for National Science Day where Dr. Vyas has gracefully agreed to come. We are now looking forward also to JRD Tata lecture, which will come up in June end, and so on. So the idea is to keep a dialogue going between TIFR staff members and TIFR alumni, because a lot of TIFR people, believe me, you know what TIFR is only after you leave TIFR. And that's when you realize what a powerful institution this is. And TIFR alumni continue to want to support TIFR activities in every way we can. And that's why this association works well, because there are a lot of people who realize the value of TIFR and would like to have the best of collaboration between the two. So with those few words, I will say that I'll just thank you all for being here and invite you also to be member of the Alumni Association as and when the time comes, because we would like to work together to do a lot more for TIFR and with TIFR, so that all of us have a good time and good memories of TIFR. Thank you.
Thank you, Professor Vaya. And now it's a great pleasure and honor for me to welcome Shri KN Vyas, Professor Mohanty, Secretary TAE and Chairman AEC, Professor Jairam Chenglur, Director TIFR, Professor Mayank Vaya, President of the TIFR Alumni Association, and all of you present here and online through YouTube and Zoom. It gives me a great pleasure to extend a warm welcome to you all. And today we are privileged to have Shri KN Vyas, sir, as our esteemed speaker. The topic he has chosen for today's discussion revolves around a matter of universal concern: global warming and India's strategies for enhancing electricity generation through renewable resources and expanding nuclear power capacity. Shri KN Vyas, born on May 3, 1957, graduated in mechanical engineering from MS University, Vadodara, embarking on his career after completing training from the 22nd batch of the training school in 1970. He joined the fuel design and development section of BARC. Here he led various projects focusing on nuclear reactor fuel design analysis, notably pioneering a groundbreaking fuel for strategic applications. His expertise extended to contributing to the design and analysis of the test blanket module intended for installation in ITER, France. And Mr. Vyas has also made significant contributions in the areas of thermohydraulics and stress analysis of critical reactor core components. Throughout his distinguished career, he ascended to the position of Director of BARC and subsequently to the esteemed role of Secretary to the Government of India, DAE, Department of Atomic Energy, and Chairman of the Atomic Energy Commission in October 2015. Shri KN Vyas's exceptional accomplishments have garnered him esteemed recognition, including the Indian Nuclear Society's Outstanding Award, the Homi Bhabha Science and Technology Award, and multiple DAE awards in 2007, 2008, 2012, and 2013. Additionally, he is honored as a fellow of the Indian National Academy of Engineers. And today also happens to be a very special day where we from TIFR Alumni Association also felicitate the young researchers' achievements. And this is given in the form of Kaushik medals. And we wish to thank Professor Ramnath Kaushik for his generous endowment in memory of his parents. And the awards are been given to the following young researchers. So I will announce the names, and I request Shri Vyas Saab to hand over the Kaushik medals to the awardees of the year 2022. So the Ramkrishna Kaushik Medal 2022 is awarded to Piyush Srivastav from STCS for his significant contribution to the paper Correlation Decay and Partition Function Zeros, Algorithms and Phase Transitions. Congratulations, Piyushji. The Saraswati Kaushik Medal for 2022 is awarded to Jaideep Sarkar from DCMPMS, Condensed Matter Physics, for his significant contribution to the paper Quantum Noise Limited Micro Amplification using a Graphene Josephson Junction. Congratulations, Jaideep. So thank you very much, Vyas Saab. Now I request Director TIFR, Professor Jairam Chenglur, to hand over the Kaushik medals to the awardees of the year 2023. So the Ramkrishna Kaushik Medal for 2023 is awarded to Saranyo Moitra, Department of Theoretical Physics, for his significant contribution to the paper Building Entanglement Entropy out of Correlation Functions for Interacting Fermions. Congratulations, Saranyo. The Saraswati Kaushik Medal for 2023 is awarded to Anirban Das from DCS. However, he is abroad. So his guide, Professor Sudipto Maiti, has kindly agreed to take this for the rational design of protein-specific folding modifiers. So thank you, Professor Sudipto, and also Anirban, if he's online. Uh, Now, heartiest congratulations to all the awardees, and thank you, sir. Now, we are happy to announce that the newsletter for the last calendar year, that is the 2023, would have been in your emails by now. This will be sent to you already. So please have a look at this newsletter of TIA. And now I request Vyas Saab to deliver his lecture. Thank you.
So, thank you very much, Professor Prabhu. First of all, I am thankful to Dr. Mohanty for having come here, taking time out. And is it all right now? Yeah. And I'm thankful both to Director TIFR and Professor Vaya that you have invited me for this particular short talk. I'm very much thankful that when Professor Chenglur indicated that I can choose a topic of my liking. So, let us say liking as well as understanding. So that's why I have chosen this particular topic. I would like to make one confession. I am among the best of the brains in India. I will be presenting some of the data. Some of the data is dated, even though I was given almost a month's time to get the fresh data, but I had found some inconsistency in the data. So what I am trying to tell here is have an overall idea about the sort of problems that we are facing rather than having the accuracy of the data part of it. I did spend quite some time, but there were lots of inconsistency and I didn't have time to sort of check for those inconsistency. Primarily the data is from internet, and that's why you know how many times some of the data can be wrong. So this particular set is definitely consistent. I have taken from World Bank or international repute organization. So net zero and relevance of nuclear power. This is a very famous graph, which is average Earth's surface temperature measurement prepared by NASA. What you see in the dark red line is the running average of 5 years, and this individual yearly surface temperature. You see practically the slope has remained same. In the second part, the slope has increased marginally, but it is not too high. So what possibly it is my conjecture that till 40s, whatever greenhouse gases that we generated, there was some sort of a feedback, and as a result of that, there was a flatness between say 1940 to 1970s or so. But after that, the industrialization has increased all over the world, and as a result of that, the graph is not showing any tendency to sort of flatten or even sort of saturate. So you know very well, United Nations has put the limit to 1.5 degrees Celsius. You must have read newspaper reports also, wherein in the last year, it was at the 1 year, it has exceeded 1.5 degrees Celsius, more 1.5 degrees Celsius more than the pre-industrial levels. So World Meteorological Organization has given many instances where increase in temperature results into severity of storm, increased severity of droughts, rising levels of oceans, and all these things are very well understood. So one of the major, when it comes to fossil fuel burning or energy requirement, one of the important things is generation of electricity. There are many other things, industrial uses, vehicles and so on. Electricity generation is not the only source for greenhouse gas generation, but we need electricity. And if you see the maps released by NASA 2012 and 2016, you see India is shining. The rise of increased usage of electricity, all the cities that you see, it is more brighter. Now, ultimately, all this translates into the per capita consumption of electricity. I have data, that's what I was trying to tell. I have slightly dated data. I wanted some consistent set of data, that's why I have kept. So if you see consumption in India and consumption in USA, there is a huge gap, and then it can give you lots of inferiority complex. So we try to compare it with world average, which is light blue, and China, which is dark blue, as compared to India. But we find that even compared to world average, our consumption is not really substantial. That is, our electricity, electricity availability to the persons are not very high. If you see initial years, early 90s, there is not too much of gap between the consumption in India and China. But after 90s, when liberalization in China took place, they took over lots of manufacturing from rest of the world, and that is why they needed more electricity, and as a result of that, their electricity generation and per capita electricity consumption increased. Now, one more data, International Energy Agency. If you see India, this is the second chart, is the same thing for different countries for 2014, whatever I showed in the previous one. This is only the 2014 numbers. So India, even though it is the third largest producer of electricity, the per capita consumption is relatively very less. And one of the reason is our very large population. It is not that in India we are producing less electricity. It is more than even advanced countries like, I would say, Japan or France or Germany. It is much higher than that, but large population results into relatively lower electricity per capita consumption. The present number, that is last year number in 21-22, it is about 1255. In 23, it is about 1300 kilowatt hour per person per year. That is the latest number. It is no longer really the number of 805. So why is it we are concentrating on electricity generation or electricity consumption? One of the parameter for Human Development Index is electricity per capita electricity consumption. There are many other factors like life expectancy, the amount of schooling that the person, the child takes, and so on. This is not the only factor, but this is one of the major factor. And as of 2023, India ranks 132 in the total list of 191 countries. Is fairly low when it comes to the overall, I would say, HDI index is concerned. So this is the data prepared by Rupsha Bhattacharya and Dr. R.B. Grover, presented in Current Science. So this is in a fairly, we are ranked fairly low. Now, when we talk of electricity, number one, whatever is the electricity generation as of now, which is going to take place, we have to replace that with something which is renewable, or I would say which is not generating greenhouse gases. And if we see the we have given a call that by 2070 we will be entering into net zero. Population of India is also going to continue to increase. So we have about 20% increase in population from today till 2060, and we will need to do replacement of the coal also, whatever existing capacity that is there. So Government of India has given a call that this is what is typically known as INDCs. It is known as Panchamrit Declaration also. To achieve net zero by 2070, we will reduce emissions by making more efficient system. We will increase large amount of electricity generation by from non-fossil fuel like solar, wind, biomass, and so on. And we will increase forest cover to the best possible extent. So these are the calls that we have given. And how I'll just come to one small, before I switch over to the next topic. I would like to mention here that primarily development care or human development index can increase if we go from rural background to industrialized background. We have seen, it is very obvious to all of us that if agricultural production is more, that does not necessarily mean better income for farmers, because there is an overproduction, and as a result of, so only if we go for industrialization, then only we can go for we can claim that we will have little better human development index. So this is population in crores. As of today, we have overtaken China. This number is dated, but nevertheless, corresponding to that, per capita electricity consumption for industrial uses. If you see China, China is manufacturing large amount of products for all over the world. But even though USA may not be producing large amount of products, but still their consumption for industry is fairly large. While if you compare India, it is too less. So unless we do industrialization, we will not be able to improve significantly our development index. And for industrialization, you need electricity so that your factories can run 24/7, or if not 24/7, at least they can run in 2 shifts every day. One more thing is when it comes to greenhouse gases, vehicular traffic also has a significant quantity. So this is just a data from a news article 2016-17. A city like Bangalore, it consumes about 70,000 kiloliters of petrol. There is one more data that petrol has a calorific value of 33.7 megajoules per liter. And last data is that typically IC engine has an efficiency at about 35% or so. Now, if you put all this together and do back of envelope calculation, monthly consumption is 70,000 kiloliters. This is the calorific value. This is the total heat provided by petrol. And if we assume 35% efficiency, you need an 100% efficiency for electrical vehicles. We need a city like Bangalore would need about 300 megawatt plant just to electrically charge. Here we are not considering any efficiency so far electrical vehicles are concerned. So a city like Bangalore, we need in 2016-17 about 300 megawatt of electricity, and which should be made available from sources like renewable. So when it comes to renewable, we have superior potential for solar, as this Wikipedia chart shows. While in Tamil Nadu and West Coast, in the Kutch region, there is a good potential for wind. So let us see how we have done. Oh, sorry. So Government of India has started construction in Badla solar park, which is the largest solar park as on 2020, 5,700 hectares. This is the location of that particular site, and it has a total capacity of 2.2 gigawatts spread over about 5,700 hectare or so. So how have we done? We are doing reasonably well. This is for installed capacity. If you consider 2010 as the base, we have increased it multiple folds. Same thing for wind power also. We have done reasonably well. It is not as good as in solar, but we have done reasonably well. But if we compare it with China, how well we have done? Once again, we find that this is the chart for solar power. This is the chart for wind power. So we have done reasonably well, but then still maybe more needs to be done if you have to switch over totally to renewables. There is a very good website, AdaniEnergy.com, wherein they provide us the data about how much is the capacity in operation, and they give the daily chart for how much energy has been fed into the grid. So I tried to look at the data between 9 to 15 November, about a little less than a week. I mean, let's say working days in a week in November 2021. Even though the total capacity which is supposed to be added to the grid is 3,000 megawatt, hardly there is a single day, maybe half an hour time or so, where it has crossed the number of 2 gigawatt or 2000 megawatt. So even though so much of solar power in principle is available, what is being pumped into the grid is much lesser. Then I felt that maybe this is winter time, the solar insolation will be very less. So maybe that is the reason. So I did the same exercise for the month in the April, where 6 to 11th April 2022, still it does not reach 3000 megawatt. It has certainly, if you compare these two graphs, you find that whatever the zigzag is there, it is not there. It is more or less, all the days are giving practically identical, excepting maybe few days here. But when you look at it little further, what has been what this site is tells is the total installed capacity is 4700 megawatt. So in just about 6 months time, between November to April 2022, November 21 to April 2022, about 1700 megawatt has been added, which is quite significant. By any standard, it is very significant. But then still, despite having 4700 megawatt, what is being pumped into grid is not really 4000 megawatt or not even 3000 megawatt. So I'll come to that little later. So and what we have done is we have occupied huge amount of area. So this is a chart by Nuclear Energy Institute where relative comparison is done. A nuclear power station of 1000 megawatt electric takes about 1 mile square area. Solar, depending upon intensity of solar insolation, it may take 45 to 75 miles square, and wind takes still bigger. So what will have to be done is, if we have to go for total renewables, we will need storage, which is not an easy solution. Silicon cells are cheap because silicon is the second most abundant element on the earth. It is easily available. Lithium is not so easily available. That too, in lithium, you will know better than me, you need very high purity lithium carbonate or lithium salt to finally make it work as a battery. So storage is not a very easy option, and we cannot store the way I showed for the month of in the month of April, for month of November. You cannot store so much. And problem of recycling of solar panels is also not an addressed solution. When you are making solar panels, you are making a system which can weather lots of hardship. It can weather very hard sun. So when you try to extract some valuable material out of that, it is not going to come out so very easily. So this problem is still not fully sorted out. So in comparison, since I belong to Department of Atomic Energy. So I say you compare Kudankulam 1, 2, Kudankulam 3, 4, Kudankulam 5, 6, 6000 megawatt electric. It needs about 1000 hectare of land. There it was 5700 hectares of land or so. So there are 6 plants which will have an exclusion boundary, whatever is shown here. And you see 1 and 2, they are operational. You see the water coming out of this, while 3, 4, 5, 6, they are still under construction. If you compare the ecological impact, what you see on the left hand side is Kudankulam 1 and 2. What you see is a representative figure of 1000 megawatt coal fired nuclear power station. Relative the land required is this is not including the I would say exclusion zone. That's why this number is wrong, not 1000 hectare and 20 hectares. So I would say you please discount this particular part of it. 160 ton of fuel every year, while here it is 4.7 million tons of coal per year. Negligible emission, while here you have emissions in form of carbon dioxide and sulfur dioxide and so on. And it will result into about 4 ton of vitrified waste per year, while here it is relatively large amount of ash that is generated. Now, when I am telling that nuclear power is good, is it really good? What India has done? If you see, it's just like, in my class also, my surname was Vyas. So it used to be in the last thing. So same way, here we find India in among the last last few people, just like Vyas, it is here. So let us see the reason. If you see the reason, India has the 7th largest fleet of reactor. With this, once again, this is dated. This is showing 22 reactors. Right now we have 23 reactors under operation. 24th has been connected. And if you see Republic of Korea, at that time they had 2 reactors more than India. But you see the difference. The amount of electricity which is fed into the grid by South Korea reactors is much larger compared to what is there for India. The real reason is South Korea, when they started making reactors, the economy was advanced. And as a result of that, all the reactors were 900,000 megawatt and 1400 megawatt later on. While in India, till Tarapur was commissioned, all the reactors were 200 or lesser than 200 megawatt, 220, 160 and so on. So even though we have 22 reactors, we are not in a position to, and I am myself, I have learned, I have heard it myself when negotiations for, in 1989, negotiation for Kudankulam power station was going on with Russian Federation. There was a representative from Department of Electricity. They said that 2 reactors of 1000 megawatt, how the grid would survive just in case if the reactor trips, the entire grid can collapse. So this was the thing. Now we have the entire Indian grid consolidated into single. So you can feed from western grid right to southern grid and northern grid and so on. So now that problem is not there, and India is now making reactors of all 700 megawatt or higher as per the present plan. So we hope that newer reactors will be able to make a more significant contribution. Now, if you see world NPP installation, you see Japan. It is so very dense, so many reactors are here. Similarly, in USA also, you see in the western coast, large number of reactors are there. If you see India, we are not in a position to really find sites. There is a fair amount of resistance to sort of from the local persons to sort of make the sites available. See, even Europe also, the large number of reactors are there. So one of the reason I would say, like in Gujarat near Bhavnagar, there was an agitation. There was a plan to install 6,000 megawatt reactors from Westinghouse Corporation. The local persons, they opposed, and as a result of that, that particular plan was to be dropped. Now those reactors will be, they are being planned to be installed in Andhra Pradesh. And then here, very poetic language, that is, Jaspara mithi vardima motna vavetar na khape. That is, we don't want to sow death into the fields of this location. So there are lots of emotions attached to, I would say, in nuclear power station, which I feel they are misplaced. I'll just try to come to that, whatever reservations that, I feel that people are not properly. As a typical Gujarati, if I say in Bhavnagar district, 6 reactors of 1000 megawatt were planned. Roughly, it costs about 30 crore per megawatt. It's an imported reactor. You expect it will cost about 30 crore per megawatt electric. Only time will tell how much it will really cost, whether it will be less or more. So there is an investment of 1,80,000 crores. Now, if just 1% of the money comes into Bhavnagar district, it comes to about 1,800 crores. It's a huge amount of money. And this is the perpetual thing. So I personally would have, if people really listen to me, I personally would have said that most welcome, please come, because it's going to generate employment for a fairly, I would say, long time. Now, one of the major reason why I would say the let's say people in Gujarat, in this region, Bhavnagar region, they were having worries was because of Fukushima accident which took place in Japan. This was in 2011. This was a very serious accident. What had happened is, this is the location. Earthquake with a magnitude of about 9 occurred in the afternoon. As a result of that, power lines to the reactors were disturbed, and as a result of that, since power was not available, plant was shut down. Just within about 15 minutes time, a very, very large tsunami of having 12-meter height struck, and it basically, all the power, all the diesel power was lost, and as a result of that, core heat up took place. It resulted into hydrogen generation, and finally explosion took place. Yes, it was a very bad accident. But if we look at the magnitude of earthquake, most of you would know in this on this earthquake, the scale is logarithmic. So when a magnitude earthquake magnitude of 6 strikes, it is equivalent to 1 Hiroshima, about 15-16 kilotons of TNT. If it is 7, it is 31 times that of 6. If it is 8, then it is 31. So ultimately, it is this particular earthquake magnitude of 9 is about 30,000 Hiroshima equivalent explosion. It's a huge earthquake. If you see it from a reactor designer's perspective, despite this earthquake, the plant did not suffer any breakage. So many roads, so many bridges they gave away. But it did not, the plant itself was safe. Second thing, there was a plant, Onagawa, which was at 120 kilometers, did not have any problem. But 180 kilometers distance, Fukushima plant had a problem. One of the reason, once again, I would say it's a very complex thing. One of the reason for this is they did not see the fact that this is Japan. The engineering was done by Bechtel Power Corporation. This is Japan, which will have tsunamis. So the foreigners could not envisage the difficulties that is there. While the local Japan, there was another plant, Fukushima Daiichi had a problem. Fukushima Daini did not have a problem. So all I'm trying to say is that certain accidents do take place. They are pretty bad. But to assume that in the coastal region of Bhavnagar, which has never seen such an activity, tsunami word by itself is a word of Japanese origin. In India, there is nothing like tsunami. It is only when there was a tsunami which came to the southern coast on the 25th of December or whatever. I'm forgetting the year. So then only we realize that there is a thing like tsunami. So possibility of Bhavnagar, which is in the, I would say, Gulf of Cambay, having this type of tsunami and being afraid that since the Japanese plant went into a problem, now Mithivaldi plant will also have the same problem. I think it is a bit of an overreaction. And still, there were no deaths due to radiation. In 2018, one person had lung cancer. 2011 was the accident in Fukushima. 2018, one person developed lung cancer, and then unfortunately he could not survive. Then when you have such fears, I don't know how many of you see Simpsons. I have graduated much beyond that. So there is an episode or something of Simpson where the person visits the nuclear power station and he finds that the operator is sitting with his foot on the control panel. I'm sure even LINAC operators will not do that. Forget about nuclear reactor operators. Similarly, plutonium is lying just like that. Similarly, radioactive fluid is, sort of spilling. So, this type of feelings get developed into the, if a young person having an age of 12 or 15 sees that, will say, yes, this is how the nuclear power plants are operated by everybody. Fine. So when it comes to, there is a renewed interest in nuclear because in my opinion, many people have realized that solar and wind is not going to solve the problem. If you say that, no, I don't worry about global warming, then it is a separate issue. It may happen in 2050 or so that you will say that, but I will certainly not be alive by that time. But in 2050, somebody would say, no, I don't worry about global warming. Let it happen. Whatever is happening, let it happen. Then it is a separate issue. But if it is going to result into global warming, then nuclear is really green. It is similar to what is there for wind power, etc. The same analysis is by EDF also. The earlier was by IPCC. EDF is also telling the same thing. UK is also telling the same thing. Now, let me be truthful. The same exercise, when it is done by German, they say that all this analysis is not correct. And I mean, they are indicating that nuclear is not as low as wind or hydro. It is significantly more, but still it is quite less compared to coal. Now, coming to Germany, Germany is a little different case. They very consciously decided that we would like to have as much renewable as possible, and they decided that it was a conscious decision by people and subsequently executed by government, that we would like to have as much renewable as possible, and we will phase out ultimately the nuclear, and that is what that was done. So you find from 2016 to 2020, more than 50% in 2020 is from renewable. And this is the typical part of renewable, where this is 42% is onshore wind, 11% offshore wind, rest is solar is relatively less, obviously, comparatively, because the insolation is going to be little less. But they faced a curious problem. January 19 to January 22. This was the average cost of, as it is, this particular cost of electricity in Germany is higher compared to other European countries, but it skyrocketed, it became too large. So if you look around, the reason is this onshore wind reduced by 16.7%. Obviously, offshore wind also will reduce. It has reduced by 15.4%. They tried to compensate by increasing hydro output by 9.1%, but still this particular aspect was far too much. They had to import electricity from European grid, and as a result of that, it has resulted into paying higher prices so far as customer is concerned. So the conclusion drawn for this particular beginning of I would say end of 2020 and beginning of 2021 is that has proven to be a wild card. It cannot be predicted. So when we go for larger and larger penetration of solar, it is going to result into a little bit of uncertainty. If there is suddenly a cloud, you cannot do much about it. You can store electricity for maybe 8 hours, 24 hours, but how much? Supposing if it is a monsoon season, what will you do? So in praise of Department of Atomic Energy, we have 7 sites which has about, as of now, we can say 24 operational reactors. NPCIL and DAE has spent tremendous effort in making Indian industry, making large components, very good quality components. This is Calendria, which is being shipped. This is N-Shield, which is being, these are high precision equipment. When it comes to erection, it has been done very nicely. This is erection of Calendria, other is erection of N-Shield. Very complex, I would say, in situ work of feeder pipe. This is typically the photograph of Kakrapar Atomic Power Station, 700 megawatt. And the final reactor just before startup, this is the particular type of photograph. So when it comes to operational, we have very good capability when it comes to construction and I would say construction and erection. When it comes to operation also, there are so many instances. Once again, this is dated. It could be, Dr. Mohanty would know, it could be 44 times or so. I'm not very sure. But so many times the reactors have operated for more than 1 year. And so many times, few times, that is more than 2 years. So you can imagine the amount of, you must realize that it needs tremendous amount of self-discipline. If you strike a welding torch also at a wrong place, or many a times you have to do periodic checking of trip signals. So if you make any mistake anywhere, the reactor can trip and then it will not find a place in this particular graph. So tremendous amount of discipline has been developed by NPCIL operating personnel. And as a result of that, this has been achieved. And this 963 days, it was, when it was achieved by Kaiga Generating Station 1, KGS-1, it was a world record at that time. Right now, it is not a world record. And that too, it is not that the reactor has operated at 10%, 30% capacity factor. The capacity factor was more than 90%. for this full 963 days of operation. Now, coming to one of the very, I would say, interesting topic, small modular reactors, SMRs. All over the world, lots of people are talking of small modular reactors. Somehow India is conspicuously absent. Maybe someday Dr. Mohanty would decide and then it will be his decision. I did not decide, so that's why it is still a question mark. But yes, SMRs, they can help into a niche field. They are necessary, and then India would be working on this sooner or later. And it will be announced. That's what I am trying. I'm not telling India is not working. And large number of reactors are there when it comes to SMR, small modular reactor, from very low power 5 to 10 megawatt to about 350 megawatt. Some of them are marine based, some of them are land based, and so on. So there are a large number of varieties. But at this stage, not many SMRs have been made. So what is being thought is when you make large number of reactors in a factory made condition, overall ultimately the cost will reduce. As of now, installation cost of a SMR is certainly going to be, I made a mention of 30 crore per megawatt. It is an arbitrary one number. 30 crore per megawatt electric for a 1000 megawatt reactor. For an SMR of 100 megawatt, it is not going to be 30 crore per megawatt. It's going to be certainly more. But when you make large number of reactors one after the other, the way it happens, like automobiles have become cheaper, so many things have become cheaper. But this particular graph is yet to be proven, because what is said is if the cost for the first reactor is unity, then second reactor will be 15% cheaper, and then it will start becoming 5% cheaper further and further. But it is yet to be proven unless somebody makes 10 reactors in a single sitting. One doesn't know whether this graph is followed or not. Now, I would like to mention the quote by great Admiral Rickover. He was the first reactor engineer, admiral in US Navy. He was in charge of Nautilus submarine. Subsequently, he made shipping port reactor, which is a civilian reactor, and he made many reactors for, I would say, aircraft carriers and destroyers also. So he has told there are two types of reactor. One is paper reactor. It is simple, it is small. Small is important because it is to be fitted into submarine. That's why it is you should try to take it in that context. It is cheap, it is lightweight, it can be built very quickly. And in the same breath, he tells about real reactor plant. These are absolutely cut pasted. I mean, it is quote unquote from him, not my thing. I fully subscribe to this. It is complicated, it is large, it is heavy, it is being built now, it is behind schedule, it requires an immense amount of development on an apparently trivial item. So something which you brush aside as a trivial thing, you never know when it will go and hit back. So that's all. I am concluding. Net zero by 2070, this is in my humble opinion, may not be achievable without nuclear power. And if I quote Ted Rockwell, who had worked with Admiral Rickover, wind, sunlight, and water power are renewable, but dilute, scattered, and unreliable. I personally believe this statement to be true. I don't say I'm right, but I personally believe it to be true. Nuclear power is complex and capital intensive, and it has been seen that the plant construction gets subjected to extensive delay. So one has to, I mean, I am not, I mean, I can speak for half an hour as to how one should achieve it or possibly achieve it. But whenever we start any work, this has to be kept into mind. Nothing is really very easy. Then DAE has reasonable capability developed over a long period with considerable struggle, and which should be utilized. We should, and that is what government is helping us to achieve that. There are 10 fleet mode reactors and we should execute it. And the fear of unknown should not cloud the decision making. Don't get directed by a set of people who have different criteria, who have different concern. Think on your own. And this is my request to all the intelligent people sitting here, that I wasn't very good, but I could have easily got one job outside DAE if the nuclear power was so bad. So, fine. Thank you very much. Thank you.
Yes, and now talk is open for questions and comments. Yeah, please. And yeah, just one minute first.
Thank you for the talk. So I heard that in US reactors, they need to stop the reactor to refuel, but in Indian reactors, you don't need to stop we can change the fuel. So how is that possible? If you can briefly explain. Thank you.
See, basically in India, we have what we call pressurized heavy water reactor. So in that, fuel is inside a tube. While in USA, many of the reactors, let's call it, most of the reactors are pressurized water reactor where fuel is inside a large tank or a very thick vessel. So now if it is a tube, it is possible to unplug the tube so that no radioactive water comes out and push in the fuel. While in USA, pressurized water reactor or anywhere, not just, let's not tell USA, anywhere in France or Korea also, since it is a very large diameter vessel of about 3.5 meter, you cannot do that partial type of opening. If you open such a big lid, which is having a diameter of 3.5 to 4 meters, obviously you will have to shut down the reactor. While in this case, let us say pressurized heavy water reactor 220 megawatt, it has got 306 channels. So what you can do is you can unplug a channel, make sure that no radioactive leakage takes place. That is, you plug it, you seal it properly and then push in a fuel, and it will not cause too much of perturbation also. While large vessel, if you open, here 1 in 306 you are opening at a time, there just it is not possible. So this is the reason. And this is the reason as to why pressurized heavy water reactor can in principle operate for infinite time. Here also on 963rd day, reactor was perfectly all right, but regulator insisted that no, we would like to do some in-service inspection. We do not know what would have gone wrong. So that is why on 31st December 2018, 2018, reactor was shut down manually. Otherwise, it could have gone on for another 5-6 months, possibly. Thank you.
Thank you. Gopu?
Very much for a nice talk. So this is about net zero. We are thinking about in 2070. How critical breeder reactors that India is pursuing will be crucial for that kind of aim?
See, typically in breeder reactors, we are indicating that we should utilize thorium. Now, everything boils down to economics. If uranium fuel cycle is cheaper than thorium fuel cycle, then installing breeder reactors on a mass scale will not be of much help. I'll tell you the reason. In reactors, it is fuel which is the cheapest thing. I mean, fuel, majority of the cost in O&M is personnel as well as the reliable equipment which have to be put in. So fuel cost is relatively less of the total tariff that you pay for electricity. About 12-15% is fuel cost. So if fuel also starts becoming expensive, it will be difficult. So when you are converting thorium to uranium-233, and if you want to do the reprocessing part of it, it will make the fuel cycle more expensive. So that is why Admiral Rickover was the first one to make the breeder reactor. It was a light water breeder, not heavy water breeder or fast reactor breeder. It was a light water breeder reactor. So technology was established. But then finally, everybody felt that the time has not come for breeders to come into picture. And same thing is for India also. India has the technology for reprocessing thorium and extracting uranium-233. Reasonable quantity. I won't say very large size plant is there, but the technology is established. What are the problem areas? That is also known to us. But then the plants will become little expensive, and then if uranium is available comfortably, that will not be the option which government would sort of allow us to exercise.
Yeah, Lokesh?
Yeah, I have questions regarding your comparison between India and China. That is always compared. So the question is that whatever the plants, either it is nuclear or is solar or wind, which is under projection that this will be built in India. Even if you add all of them, suppose they are built today, what will be the fraction of with comparison with China?
No, see,
Will catch up somewhere?
I personally feel why I try to compare with China is that in 1990s the gap was relatively less. That's why I mean I try to do that comparison. In case of China, if you see, their electricity production is even higher than USA. So we don't need to produce so much of electricity using nuclear or wind. All I'm trying to tell is that the pace or the focus, we feel we are doing a good job, but by 2070, whether it will remain to be good enough or not, that is only for the next generation to sort of worry about. So this is all I'm trying to tell. Like for example, as of now, country like France, country like USA, their nuclear power station, they do get delayed. It is the, I mean, and they are the original designers. But the similar plants, they are able to, in China, they are able to put more focus, more concentrated effort, and they are able to do the timely completion. So the, I would say, intensity of effort that has been put in any of the activity, they have realized that if they have to reach net zero, tremendous amount of effort and concentrated sort of concentration should be put into this, and that is the only reason for showing those two graphs.
Hello?
Yeah.
Thanks for great talk. So I have two questions. Both are kind of related to sustainability. So can you please explain how to deal with the nuclear waste as it gets produced? And the other question is, when we use the nuclear fuel, how much of it we can find in India and how much do we need to import?
See, this first question, India still has very low amount of uranium reserves, and whatever reserves are there, the grade of the ore is relatively low. So, and earlier those reserves were not even sort of, I would say, discovered. So India had right from beginning decided that we'll do fuel reprocessing. So when you do fuel reprocessing, overall volume reduction takes place. So when you are taking the full fuel assembly, which is the spent fuel assembly coming out of the reactor, the volume needed is very large, and that is why you will hear that in Sweden and Finland they are sort of putting it into the deep mines. In USA also there was an idea that in Yucca Mountain these caverns will be built and so on. While in case if you do reprocessing, they had chosen not to do reprocessing. They had the reasons which is decided by, I would say, the nation as an integrated overall approach. When you do reprocessing, you can do segregation. For example, you can segregate relatively low half-life radioactive products and keep them separate. Long half-life products, you can keep separate them out. And just to give an example, if you BRC has developed the technology for americium separation. Now, if once again it is technology to a reasonable scale, I won't say it's a very large scale, but if say Department of Space needs that americium to work as an radiothermal RTG or RHU, that americium can be provided to them. So number one, it is getting utilized. In case if it is not needed, or other you can say transuranic elements, whatever that are there, minor actinides, those can be burnt into fast reactor. So the problem of waste, which is going to have a half-life of say 5,000, 10,000 years, it gets eliminated as a result of that. So I personally feel that rad waste problem, if you have taken a decision to do reprocessing, it is not an insurmountable problem. If you decide not to reprocess, yes, it can cause a problem. And second thing about the you said about that uranium part of it, compared to I would say foreign countries like say Kazakhstan or Canada or some of the African countries, Our uranium grade is low, so our uranium is as such will become more expensive. So I would say the normal method would be India and government of India can decide to what extent we should use indigenous uranium, to what extent we should use imported uranium, which is being imported, and as you may know. So is the policy decision by government of India to what extent we should exploit our own resources, and so this is what it is. But it is not very insignificant, but the cost of processing our ore is high.
Yeah. One more.
Hello.
Yeah, please.
So thank you for the excellent talk. So I have one question. Is it possible to achieve this net zero emission through this green hydrogen energy?
Ek minute, I'm not able to see.
Sir, I'm
Oh
here.
yeah, sorry.
Is it possible to achieve this net zero emission through green hydrogen energy?
No, but see, it is like this. For producing green hydrogen also, you need some energy. There are sort of two processes. One is thermal process in which you do dissociation of, I mean, say H2O into 2, or other thing is electrolysis. So both of these need energy. So from where will you get that energy? So either you get it from solar, that is solar thermal, that is you heat up, you concentrate solar heat in such a way that you get 1000 degree, 1200 degree centigrade temperature, I would say temperature source, and you use any chemical dissociation process, or you use solar panels and generate electricity, and then you do electrolysis. But these are, as I personally feel, this is not the field of my understanding. So as I feel, it is not a very, I mean, it's not a very easy thing. To a great extent, India is a huge populous country. So it is not very easy. Yes.
Yeah. Rajdeep and then Saurendu.
One question, and because this comes up many times when we try to do new nuclear plants, part of the technology is imported, or often we want.
No, for 700 megawatt, everything is Indian.
Okay.
Yeah.
So, because at some point the issues of who gets the responsibility if something goes wrong and became an issue in the country. So my question was, I think you are close to answering my question, is that what part of it can we do ourselves, and what part or what amount beyond which we would need, let's say, foreign installations or things like that?
See, for pressurized heavy water reactor technology, that is 700 megawatt, what was just dedicated by Honorable PM just a few days back. More than 95% is from India. Very small things that is imported, but that is still more from the consideration of convenience rather than, I would say, inability to do. And that goes, lots of credit for that goes to NPCIL. So the plants are designed by NPCIL. The plants are fabricated by Indian industry, but NPCIL takes the full responsibility for the performance of the equipment. So industry is not responsible, and NPCIL operates these plants also.
Thank you. Saurendu. Saurendu.
Yeah, I mean, comparison between different renewable methods, I was wondering how they hold up under the next 10, 15 years of climate change. Okay, so one thing that we learn from these IPCC reports is that the number of cloudy days or more moist days is going to increase. And the second thing we learn is sea level rise. Okay, so now increase in the number of cloudy days will of course impact solar. Okay, and sea level rise is likely to impact both wind as well as nuclear. So do you have, are there estimates or whatever?
See, basically, yeah, thank you very much. See, basically, Sea level rise, I can give my sort of opinion about sea level rise for nuclear. Sea level rise for nuclear, there is tremendous amount of, I would say, design margins built into the nuclear power station. When the Indonesia tsunami came, Kudankulam was extremely safe. Because I'll tell you, this is what makes at times nuclear power station little more expensive, because little by little things start getting added up. So all post Fukushima and even before that, there were some flooding incidents in different parts of the world. So diesel generator sets were started getting raised. So if at all I am having a reactor, I would be forced to make my emergency DG sets maybe equivalent to, let us say, 10 feet above. So sea level rise per se is not going to affect operation of nuclear power station. It is as per my, because there is fair amount of conservatism built into this. For example, post Fukushima, AERB did review of all the power station, whether they are on the coastal region or somewhere near the, say, dam site and so on. So all those reviews were done, and immediately after that, the operators were asked that you take these cares, then only we'll give you permission to operate the reactor. So they were given a period. They were not asked to shut down the reactor, but they were told that within 6 months times or 9 months time, you do these changes. So all regulators for nuclear system, they are extremely, I would say, cautious, because all of us are aware of the, let us say, psychological as well as real bad effects of radiation. And about wind and solar, I am sorry, this is not the field of my understanding. So I would not like to give any comments. But I still personally believe, rightly or wrongly, that comment by Ted Rockwell, that it is too dilute. I would like to put 2 also in, he had not put 2. So it is too dilute, too unreliable. So I would not like to bank everything. At my home, I have installed solar panels. I'm going to get my own data rather than depending upon Adani Energy.
Yes.
Yeah.
That India is producing nuclear power. Situation is same. When we installed the first nuclear power plant, there were objections from the village people. Even today, if you going to make a nuclear power plant, same thing. We are not able to reform the thought process of the people, despite giving all the merits of nuclear power. Everyone says, yeah, it is good, not in my backyard. What is the status of DAE in this progress? We have been progressing in so many places, but we are not able to convince the people of installing a nuclear power plant anywhere.
Yeah, no, your observation is very correct. All of us, we have a feeling that not in my backyard. I do agree, but then my submission here is only this: only the leaders, they can change the public opinion. Even though I may be able to speak Gujarati, but I don't speak the language of the persons who are really on the ground. So even if I go and speak to them, it is not going to help. So that cultural change has to come gradually. It will come sooner or later. I personally feel, I am quite hopeful. There are, I would say, almost more than 450 reactors, or almost 450 reactors as of now, which are operational, little less maybe. Few of them have been decommissioned. So there are so many reactors. You saw Japan coast also. You see, there is hardly 100-kilometer distance between 2 nuclear power stations. And here in India, there is a power station at Tarapur. Then you go about 200 kilometers, 250 kilometers, little bit north or northeast, and Kakrapar. Then you go about 800 kilometers. So this is This is not a good thing, and I hope sooner or later we will all realize. And I will tell you from my personal experience, the amount of prosperity that it brings to the local is tremendous. I have myself seen when in early 80s when I used to visit Kalpakkam, they were all thatched roof huts. Now, I would say, I mean, it won't be very. They are all reasonably educated set of people who are dependent upon nuclear power station to get their contracts. Or I mean, there are so many services needed. You don't need really, let's say, training school graduate to sort of get employment in. There are so many ways and means. So I personally am hopeful, and this job cannot be done by me, or I would say Dr. Mohanty is more capable than me. So Doctor, I would hazard that guess, but DAE will not be able to do because we don't speak their language. We have to be among them, then only it can help them. Yeah.
So the availability or accessibility of power also depends on the cost, especially in a remote country like ours.
Yeah.
So if we take into account the lifetime cost invested and also the operating cost, how does it compare to, let's say, thermal or solar, the per unit electricity? If we think about everything.
Still, NPCIL is able to sell electricity, and even newer plants, NPCIL is able to sell electricity. So, if you get reliable electricity, for example, I am not very sure, but I had heard this type of rumor. Government of Gujarat was very keen that all 700 megawatt they wouldn't mind buying from NPCIL at so-called relatively higher cost compared to what they are used to giving for solar. So this is where I would like to just indicate, say, let's say at my home, I have solar panel, and I'll say I will finish my dinner at 7 p.m. Fine, there is no electricity, no problem. But when you have to run industry, these things are not easy. When you want to run your servers runs 24/7, you need electricity, you cannot depend on backup. And this is where, even if it is expensive, and one more thing let me try to tell, nuclear becomes expensive because rate of interest in India is very large. Otherwise, NPCIL plants would have costed little less. I won't say very dirt cheap, but it would have cost less. Similarly, if there are not agitations by people, in Kudankulam it happened. Kudankulam, the plant was ready. Just before that, Fukushima happened. And there was a huge agitation. Who will pay for 6 months of 100% completed plant? I mean, interest starts running. So this is where I feel I think it is a combined thing. It is nothing like my technology or your technology. I mean, either you believe this is all right or not all right. But specifically in case of nuclear, these are very long-term decisions. You cannot do you cannot do flip-flop on that. No, I made a mistake 5 years back. I mean, you have to go full-fledged into this. I don't know whether it satisfies you or not. But electricity is competitive, and that is why state governments are ready to sign power purchase agreement the moment reactor starts operating.
Okay, so these last two questions, one from Professor Acharya and Datar, just sitting.
Young boys have already got fed up.
My question is regarding the radioactive decay time of the spent fuel. So there were plans to or proposals using the accelerated beam to reduce the time by spalliating the fuel and reducing. How far one has come down now in the decay time of the spent fuel?
Decay time?
Yeah.
No, decay time.
Radioactive decay time.
Decay time will depend upon the type of radioisotope that you are sort of you are trying to think of.
Yeah.
So if you have things like, say, cesium, etc., it will have a half-life about 30 years or so, if I'm not mistaken. If you talk of americium, it will be 10,000 years.
No, what I mean is by making it smaller and lower radioactive elements like that by breaking down, how far they have.
No, so ADSS. No, see, typically there are two ways. Basically, for breaking down, you need high energy neutrons.
Yeah.
Either you get from fast reactors, which has got reasonably high energy, and you talk of ADSS, where you have more than one GeV beam, and then you have extremely high energy neutrons. So what I understand is BARC is sort of setting up or trying to understand the high energy proton accelerator technology. We have so far achieved some milestone of reaching up to 20 MeV or so. Further work is continuing to medium energy, and then finally 1 GeV.
Yeah.
So it will take some time. The solution is not readily available.
I know. What I meant is, world over, how.
No, world over
much,
also nobody
has
got high intensity and 1 GeV proton beam. This is what my knowledge base. Dr. Datar,
My question relates to this graduation from 220 megawatt to 700 megawatt.
Yes, sir.
Heavy water based reactors. Is 900 megawatt a goal? Because I think Canada started with such reactors. Or what are the technological difficulties involved? Is it to do with Indian industry or is it something else?
No, see, my thinking is like this. We made 540 megawatt reactor. Now the same core has been, I would say, operated to give 700 megawatt. And with some post-Fukushima, whatever corrections which AERB asked us to do. At this stage, I would not recommend to go for a 900 megawatt reactor because it will involve newer engineering. There are no technological challenges, but when you have higher capacity reactor, the pipe sizes will marginally increase, maybe 10%, 15% diameter. So all those things is going to need re-engineering, and in that some mistake can take place. So my suggestion would be, we make all 700 megawatt one after the other. 10, 15 years down the line, we say that we repeat 700 or we now graduate to 900 or 1000 megawatt. So Canada had higher capacity reactor. They have not made it, they have designed it. So NPC 4-5 years down the line, they may think of starting a design of a larger capacity reactor, and then whether to really construct or not, that can be decided later.
Yeah, and the last question for
Yeah, thank you. No, I just wanted to go back to an early slide where you had shown the footprint of a solar power plant compared to a nuclear power plant and so on. And I think solar was about a third of wind. So if we were to make a strawman proposition that you meet net zero just with solar, ignoring the fact that it's unreliable or whatever, but just, the difference between installed capacity and actual power that you get. But even if you take those very generous assumptions, can we at 2070, what fraction of the power requirements can actually be met by solar?
I personally have doubt. I have not done that back of envelope calculation. How much is the land available, which is not a forest land, which means you don't have to cut any trees and so on. And so practically the Thrastan and Kutch region, in my opinion, it will be not more than about 30% of the present coal installed capacity. But since you have prompted it, I will try to do that back of envelope calculation.
I think the solar power panels are now at about 30% efficiency, probably.
Yeah, about if it is single, if it's not polycrystal, if it is a single crystal, yes, about 30%.
Yeah. But that, again, one could put a factor, but your argument is that even if you put all those things in an improvement in efficiency, you will not get there.
Because 70% of the total electricity generation now is from thermal. See, there is one more problem. Hydel is very good, but whatever water that is there, whether you will use for irrigation or for electricity generation is a very judicious thing. Not all dam sites where you get an outfall and it can go to canal. Sometimes it has to go down the river only. So So these are all very complex, and as as you know, I am an average mechanical engineer. So these are difficult questions to answer.
Okay.
Thank you.
I think Professor Vyas, thank you so much for such a wonderful talk. Uh, I mean, he has really touched everything true to his name. Vasu Chistam Jagat Sarvam, as they say it. So thank you so much for coming here and gracing this occasion. And as in your Gujarati, you say, no, mar more na picha rangwana pade. So that is the peacock's feather. You don't have to praise. True to himself, and it's such a beautiful lecture and such a nice, so knowledgeable thing. So thank you very much, sir, for coming here. And also thanks to all of you. Please join us for high tea outside. And thanks once again. See you next time for the Wednesday colloquium. Thank you.
So if 10% of you are convinced